Okay. As for the rest of the announcements, so we have a survey. Check that out, please. It's going to be very similar to the one that you filled out in Unit 1. Just fill that out again real quick. It takes 5 to 10 minutes max. We use the answers in there to change how we develop our curriculum, to change how we handle TA groups. We definitely value your feedback, so please get that filled out before next class on Monday. And also, I did want to talk a little bit about, because we're getting toward the awkward part in the course where burnout starts to set in. And it can be a little, we came from Unit 1, and after completing that, we start Unit 2, we're dealing with a whole new language, and things can seem even more overwhelming for some learners. Maybe we're in a TA group where the vibe is different and it's a little more difficult to get engagement going, or maybe the instruction isn't quite what we're used to, or maybe it's just grappling with Java and not liking Java as much as the JavaScript chapters, and starting to think about, okay, well, what is coming afterwards? Like, is this what I want to do? I think a lot of doubt can start to settle in the beginning and middle of Unit 2. So I just want to say, if you're experiencing that, that can be pretty common. It remind yourself of why you signed up in the first place, of where you would like to go, what you'd like your career path to be, what you're working towards, and know that it is a common experience, but it can also be a good time, for TAs and for learners alike, to kind of rally, be like, okay, I know this is a part of my learning where I've learned a lot of the basic things, and often there can be a perceived plateau after that initial burst of learning where you've picked up all these skills, but now it's like there's so many more things to learn. But we're just, keep in mind, we're just getting started. You don't have to know everything by the end of Unit 2. Certainly you won't know everything, but everybody here is on the right path. So I just wanted to say that real quick. And that is all I have for announcements. I'm certainly available through Slack if you have any questions, comments, concerns, and I will see y'all on Monday. Have a great studio.
Thanks, Colin. All right. Tonight we are on Chapter 7. We're going to talk about class inheritance. This topic is not new to you because we did talk about class inheritance with JavaScript, but there are some new elements that you'll be introduced to, some new concepts specific to Java. So we will get right into this with our usual format. Colin already mentioned the student survey. Your TAs should be giving you some time tonight during studio to fill that out so you can just get it out of the way. The graded assignment 2 deadline was moved to the 2nd for anybody who missed it. As of tonight, you will know everything that you need to finish it. Inheritance is kind of the last piece. And then that intro video I put together is available. That playlist is at the top of the class announcements in Slack. Hopefully that'll help give you a little bit of orientation to the assignment. And I mentioned a few things along the way that hopefully will help you, get across some hurdles. And actually, some of the live coding I'm going to be doing tonight is going to be really beneficial for a graded assignment 2 as well. So, okay, let's get into inheritance. When you create classes from other classes, we'll talk about the terminology that's often used with Java and inheritance, what the syntax is, the concept of abstraction. I'm going to introduce a new code example, or we're going to base things on a little bookstore. And then we'll talk a little bit about what it means to test classes with inheritance, and then also to diagram classes, which is a very useful skill. All right, so inheritance terminology. There are lots of different ways to talk about classes in JavaScript. We mostly refer to them as parent and child, right? So we're going to be also using these terms. Subclassing is another term for inheritance. So you'll see things like base class and superclass to refer to that parent. A child class can also be called a derived class or a subclass. Mostly you're going to hear me talk to them about them as a base class and a subclass. And you remember in the JavaScript unit, I had my example with the beverages and how we could have that kind of grandparent class of the beverage, and then water, juice, and soda could be derived from that. And then from soda, that can also be a parent to, diet soda. So I'm going to use a few of those more familiar examples on my slides, and then we'll get into the bookstore stuff when I do the live coding. So establishing inheritance in Java looks an awful lot like it does in JavaScript. You're going to use that extends keyword that you used before. Just to say, I want this class to be based on this class is essentially what that means. And while a subclass can inherit from only one other class, it can also be a base class for another class, another subclass. So here's an example where we're using the extends keyword to base soda off of beverage, but then also base diet soda off of soda, right? So that means these base classes, the original base class is beverage, and then soda is both a subclass of beverage and it's also a base class for diet soda. And then diet soda is the subclass kind of at the bottom of that hierarchy. So this part is not really new to you. This is pretty much exactly the way it is with JavaScript. And constructors are not going to be much different, actually. Whenever you want to use the base classes constructor, because Java actually operates with a default constructor behind the scenes, if you don't create one, that it implicitly gets called if you don't actually, declare one in the child class, either in the subclass. But when you are actually, you have parameters, you need to have a custom constructor. You can use that super keyword, again, very similar to JavaScript, to call the base classes constructor to pass in those values so that they can be applied to those fields that are actually defined in the base class. And then you just add on any additional things that you want this particular class to have that aren't being inherited. So you can see this example. I've got this, beverage, defined here with name, ounces, and container, right? And we're also setting an ID with a static next ID variable. You guys are going to get real familiar with this pattern. And then I say I want soda to extend beverage. So my constructor looks a little bit like this. I have name, ounces, and container that can be passed into a soda object, but I also have this new one, caffeinated. It's a Boolean. So in order to set the values of the first three into the fields that are contained in beverage, I just call super to stand in and say, I want to call the constructor from the base class, pass those three in, and then here where the new one has been introduced, you actually set the value for caffeinated because that field is defined in this class and not in the base class. Okay, so again, that's the same way that JavaScript does it. So hopefully this looks familiar to you, even if it's been a while. All right, so let's say you want to modify behavior. You have something that's inherited, but you want to override it. That override annotation that you've already been using, because you've actually done this, right? We were overriding toString from the object class, and we were, overriding equals and things like that. It's the same thing, but you can do it with anything you want, not just the ones that are defined by Java. So I'm going to demonstrate that for you tonight. We're going to have one other thing that I'm going to override besides toString. But again, when you use override, the methods have to have the same signature. That means that they have to have the same name, the same return type, the same parameters. But you can, set it in the base class and then redefine it in a subclass. So this brings us to abstraction, because Java has this concept about an abstract class. This is the idea that a base class can say, I want things to have these fields and these methods. Those will be inherited by all of my children and grandchildren, right? But I'm never actually going to create objects from that class. If that's true, then you can just make it an abstract class just to define things and require them of any classes that inherit from them. And you just use an abstract keyword right after your access modifier, like, public or whatever, but before the class keyword. And when you have an abstract class, you can also use the abstract keyword on methods. And you can say, I want to declare this method that I want to require of all the subclasses that inherit from this class, but I'm not going to give it a definition. That's the only way you can do it. You can set abstract on it if it's in an abstract class and if you don't define it there. But instead, basically what that does is it absolutely requires that any other classes that you create from this class must have a definition for it, unless they're also abstract. So I'm going to give you some good examples of that tonight, so that you can kind of see how that works and why you might make the decision sometimes to make something abstract or not. So have no fear. We're going to jump into this in just a minute and start to look at what this looks like in reality in the code. So let me just introduce this new example that I'm doing. So let's say you've got a bookstore and everything you sell in this bookstore can be represented as a product. Okay. But you then start breaking it down. You could split that into major categories and then into minor categories. So you say, okay, I've got books and I've got merchandise, but I might also have used books, right? And in my merchandise, man, I could have all kinds of categories: apparel, drinkware, you could go on, calendars, journals, I mean, lots and lots of things, right? We are not going to code all of those classes, no worries, we're only going to do 2 of them. But you can see how just thinking about things in terms of splitting it out categorically helps you think through how you might set up this hierarchy with the parent, the base class being something that you want all of the classes to have in common. And then from there, you can start to get more and more specific through, more specific definitions as you go down the hierarchy. So we're going to do this. We're going to make this work. I actually already have some of these classes coded. And what we're going to do is take them and modify them. We're going to refactor them. And when I said earlier that you should pay attention, I really meant it, because you're going to do something similar to this process for your graded assignment, where you're going to be taking some classes that are already defined, and then you're going to be modifying them so that you can use abstraction. Okay. So I've got here a product class, and it has, ID, name, description, price, quantity. These are things that I know every single thing that I sell in this bookstore, I want them to have these fields. Now, some things might need some other fields that are very specific, but these are very generic and I want everything to have them. So I'm going to set this in my product class so that as the base class, it will require, that these all be kind of set for everything else that inherits from it. So I, declare the fields. I have a constructor that will take in the 4 here, everything except the ID, because we're using next ID to assign that. And then I assign the values through the constructor. I make sure to increase next ID every time it creates a new object. This is what we've talked about in past classes. And then I have some getters and setters. For ID and next ID, I only have getters because I don't want to be able to set those again. And then the next ID we're setting right here. That's how we're handling it. But I have getters and setters for name, description, price, and then on quantity, I've got a getter, but I've decided instead of a traditional setter, what I'm going to do is have these 2 methods, these instance methods, to just say increase the quantity by this amount or decrease the quantity by this amount. And then I can call those instead and do it on a relative basis instead of just assigning a new number, because it's going to use the existing number to calculate it. Then I have this overridden toString, which of course comes from the object class initially. And I'm saying I want to list all this information out just so I can see all the possible information about it. That's really how I plan to use toString. It's not meant to be pretty, it's meant to be informative. So I've set this up, and you might notice something new here. Instead of using the \n new line character, I've introduced this system.line separator, which basically says if you are on a Windows machine, for example, it's going to return \r\n because it requires that extra character, escape character. And if you're on another system like a Mac, it's going to return \n. So it just makes it specific to the system. But that's essentially all it is it's a new line character. But I've assigned it to a variable so that I can use it over and over without having to do this part over and over, okay? That's going to be helpful for you in a certain assignment coming up, which they, Launch Code does talk about this, they introduce it, but I wanted to show you in practice what it looks like to use it, okay? So in this case, I've just said, you know what, I want everything to be on a new line, so I'm gonna go ahead and just tack that on after everything. And then I've listed out all of the properties that are defined in this particular class, okay? And we are going to add another abstract method down here, describe. We'll do it in a minute. And basically say, although we could do it now. We could do it now. Yeah, let's do it. Okay, so one thing I want to do is I've decided if book and merchandise are going to inherit from this, I'm never going to create an instance of a product. I'm only ever going to create objects from its children. So I don't really need this to be a working class. I can make it abstract so that it really is just setting up the definitions for things. And then, I'll create objects of other classes that inherit from this. So that's the first part, is to make it abstract right there between public and class. Then down here, that means I can actually create an abstract method called describe. And you may remember I said on the slides that in order to do this, you can only do it if you're in an abstract class, and you can only declare it. You cannot define it. So I'm going to say public abstract. So there's that keyword on this method. I have a return type. So the signature, you have to set the signature. So I'm saying it's a string, and I'm just going to call it describe. I don't need to set any sort of parameters for this because it's going to use the fields that are available in the class. But that's all I need to do. And so you just do that, stick a semicolon on it, and now you have declared it, and you've said what the signature needs to be. And now every single class that inherits from this abstract class will have to actually provide a real definition for this with a body, okay? So we're just gonna do that for now. And now let's go over and look at book and merchandise. So you'll notice that book has all these things in common, right? Name, description, price, quantity. It's setting them all here. It's got all those getters and setters. Down here, it's got all these lines with the exact same information, right? So what we can do is we can refactor book to inherit from product so that we don't have to redefine all these things. And if we ever update product, book will automatically, be able to be updated in the same way very easily. So I'm going to take off everything that belongs to product. I'm going to start cleaning this sucker out. So here we go. I'm removing the fields. I'm removing these. And instead, I'm going to call super to call the constructor from product and say, pass in name, description, price, and quantity. And that will, but I do have to actually say that I'm extending product. Otherwise, it doesn't know what I'm doing. So let's do that first. If we want to inherit, we have to use that keyword, and there we go. Okay, now when I did that, did you notice how it's got a red squiggly line underneath it? And you're probably thinking, oh no, did I do something wrong? You didn't, because what it actually says there in the tiny, tiny print that you probably can't read on my screen, it says class book must either be declared abstract or implement the abstract method describe in product. So IntelliJ is telling you, hey, you've just decided you want to base this on another class, and there's an abstract method there that's required, and you haven't implemented it. So that red squiggly line is not going to go away until we come down here and do this to do, where we define that describe method. Okay, that's all that's saying right there. So let's keep going from the top down. So we don't need to level up next ID there, because that belongs in product. We can get rid of all of the getters and setters that are part of product. So I can get rid of that. And then the only getters and setters I've got are author, genre, and format, because those are the only ones that actually belong to, and we can get rid of these two, that belong to this particular class. So here's something. You might say, okay, well, what about this, right? Because we have product information, and then these next 5 lines, those also exist in the parent class, right? So this is pretty cool. We can actually call super.toString and say, I want everything that's in the toString method from the parent, from the base class. And then I'm going to tack on a few more lines. So this is a pattern that you can use sometimes when it's convenient, that you might say, I want to start with a toString method that has this much information, and I just want to build a string and just tack a few more things on. It's not always what you're going to want to do, but in this case, it's a good pattern. So we're going to work with this, and I'm going to say, okay, for this particular class, for the book class, I want to use everything that's in the toString method from product, but I also want author, genre, and format to be added on. So this is how you do that, super.toString. That's how you call methods from the base class. Okay, so now we get down to this part where we need to define describe, because we're required to. I'm going to show you something cool. We love our IntelliJ generator, right? So you can actually use the generator, and where it says implement methods, that's referring to things that are required. So it automatically knows, hey, that describe method is required by this abstract class product, so why don't we grab that? And it goes ahead and gives us the signature. And then all we have to do is fill out the body and put in this definition that we want. So what I want to do for this is I actually, let's see, make sure I get the right thing. Yeah, I'm going to do something that starts to look a little bit similar to what I'm doing here. I'm going to make use of the line separator for the new line. And then instead of returning null, which was just the default for the kind of thing that you're starting with here when it gives it to you from the generator, I'm going, oh, and I also want to do this. I'm going to use this pipe character a lot to separate things out. So I'm going to create a quick little string here that just has space, pipe, space, and then I'm going to use that a little bit. Okay, so I'm going to say get name so that we can get the name from the product class. And then I'm going to say space by space. So I'm doing, name and author, right? So I'll add on author. Now, author is specific to this class, so I can actually access it directly. I don't have to use a getter, but you can use a getter if you want. I decided that for tonight, just to demonstrate this so you can tell the difference between the ones that I'm getting from this class and the ones that are coming from being inherited from the parent. I'm going to, use the getters for the ones that are coming from the base class, and then use the actual field names for the ones that are, in this class. So we'll do author, and I'm going to have a new line, singular. And then I'll say get description, which is also something that's coming from product, and then new line. And then here, I'm going to say genre, which is in this class, plus pipe, plus format, plus pipe, plus get price. So I want to put all of this information on one line. So I'm just going to do it like that. And then we'll have, 3 lines worth of information formatted very nicely. It's not just informative. It actually has, a little bit of style to it, as best as we can do with just text in a console, right? Now, I have not created any objects of this class yet. So, we have to have some objects in order to actually call this and see how it comes out. Which we could certainly do if we'd like to. So now that we've got this worked out, why don't we go over and actually create a book? And in the main class where I have my main method, And then we can test some of this out, right? And then we'll come back later and add some more. So I'm going to create a book. Book 1 is a new book, and I have to actually specify. You guys remember we had our library stuff going for a while, and now I've got a bookstore, and so I have lots of book classes, and so it just needed to know which package to get it from. That's all. Okay, so new book. I'm gonna say, you know, Pride and Prejudice. It's a classic. And this timeless classic showcases Austen's wit and winsome characters for the description. $12.49. I'm going to say there's going to be 6 of them in stock to start with. The author is Jane Austen, and it's in the romantic fiction genre, and it's paperback format. So I have, you know, all of this information that I'm putting in to instantiate an object of the book class. And by the way, if you ever forget where you are and you can't remember what order all your stuff is in, you can hover over book right there, and it shows you, you know, everything that's required. It's part of the signature there. So it's a helpful reference. Okay, so we've got that. Let's print it, and we're going to see what happens. And this, of course, if we print, just print book 1, just like that, you may recall, it automatically calls toString when you do this. If you, which is why we overwrite it, so that we don't see the location in memory, and instead we see some nice information formatted the way we want. And then down here, we can actually see it described if we say, you know, print the book 1, but let's call the describe method specifically. So let's run this and see what we get. Okay, so I don't know if you can see this, but pull this up. Okay. So first is our toString product information, and it has everything line by line, just as it's ordered. And of course, you may recall that these 6 lines are coming from product. These 3 lines are the ones that we added on in book, right? And then this is what we defined entirely in book. It's just that we set it as an abstract method in product to require that it be defined. So this is how this is going to work, right? We're going to make all these classes work together, and we're going to cut down on our code, streamline things by having this abstraction. So let's do this one more time with merchandise, and then we're going to take a break, I believe, and then we'll do a little more when we come back, because we're going to talk about a little bit about unit testing. We're going to talk about diagramming classes, and then we'll fill this out a little more. So we want merchandise to extend product, just like book did. And so we need to refactor this to work with that. So again, taking off everything that belongs to product, right? The only things that belong to merchandise that don't belong to product are category and theme. So here I can do super and say name, description, price, and quantity. Also, actually, by the way, if you are setting this up for the first time, you can use the generator to create a constructor, and it recognizes that category and theme are the only local fields. And when you say, okay, look what it does. It automatically creates that call to super for you. And it makes sure that everything is in there that needs to be there in the right order. So this is a quick way to create a new constructor if you're doing this from scratch. Okay, and then we can take out everything except for the category and theme related getters and setters. And these other instance methods that I wrote. And then we can do the same thing here that we did for the toString in book, where I can just call super.toString to get the first 6 lines, and then add on category and theme. Because that's what's specific to this class that's inheriting from product. So now the last thing to do is to, the last thing to do for now is to just define the describe method that's required here, and then it should be happy. So I'm going to go over and I'm going to borrow from this because it's going to look a little bit like this. So let's just borrow from book, and then we'll customize it to make it work for what's actually here, because we don't have author and genre and format, and I might want to mix these things around a little bit, right? So I'm gonna go grab my notes. Oh, okay. Yeah, I forgot about something. I should have paid attention to my to-do at the top. And I also should have paid attention to what this to-do actually said, because what it says is pass on abstract describe to be defined in subclasses. So we're eventually going to make some subclasses of merchandise. So we don't want to define it here. We want to pass it on. So what I actually want to copy is this, because we're saying, we're keeping it abstract for now. And because we're not going to create objects from merchandise either. We're just setting up definitions here. I have to make it abstract up here if I'm going to have it abstract down here. Okay. We're setting this up as, just more things that all of the subclasses are going to have in common. And those two new things are category and theme, right? So we've taken care of all of that. And then when we create very specific classes from merchandise, that's where we'll define that describe. We'll tack on additional information to this. It's going to be cool. Okay. So here again, I'm not going to create any, since I'm not creating any objects from merchandise, we're not going to do anything more in the main method just yet. We're going to wait until we can create some subclasses for merchandise, and then we'll create objects of those classes. All right. So who has questions after I did all that? Anyone? There. Okay, Yumi?
Yeah, I was just wondering if you could go over why you didn't need to use super for the ID field in that example.
Oh, why it's not included here?
Yeah.
Because we aren't passing in the ID when we create an object, we're not coming up with it ourselves. We're allowing next ID to define it. So we start off with a next ID of 1. This is a static thing that's stored at the class level. So class is keeping track of what the current value is at all times. And then right here, we set ID to be next ID. It doesn't come from here because we're not passing it in. And then we increment next ID so that the next object that's created from this class will have a new number. Yep, that's why. Any other questions? Nope. Okay, that's cool. All right, well, let's take a 5-minute break. Everybody give yourself a little brain break, any other kind of break you desire. And when we come back.
Sorry, I have a quick question.
Oh, yeah, sure.
I was gonna say, why can't we just increment ID instead of next ID?
Because ID is that's a very good question. ID is an instance variable. It's an instance field. So you need every single object that inherits from this class to have a unique ID, right? So the object, when you instantiate it, it's going to set that ID field with a specific number. And I've made it final. So once we set it, it's never going to be able to be changed. But we also need a way to change the number so that no two objects of this class have the exact same number. That's where the static one comes in, static versus instance. And this one is stored at the class level, not at the object level. So we're going to continue to increment it so that every new object of this class gets its ID gets set with a unique number.
Okay.
Yeah.
Thank you.
Sure. Okay. All right, let's take this break. We'll come back. We'll talk about testing briefly and diagramming classes briefly, and then we're going to get back into some live coding. Okay, welcome back. I'd like to talk about testing subclasses. This is going to be brief. We'll just do a couple small examples. Generally speaking, it's a good idea to use unit tests to verify inheritance, because if anyone ever comes back in and starts refactoring and adding things to the base class or whatever, suddenly you might start having problems with the constructors in the subclasses. So it's a good idea to have those unit tests just there to catch any problems that come up. So we can go over and we can do this. I've got a file down here in my test folder that's in the same, structure. Remember that we keep these parallel, right? So I have class 6, I have a books package, and then inside that I've got a file called book test that corresponds directly to the book class in my regular files. So we're just going to do a couple of these real quick, and just to kind of test a couple of fields that are being inherited. So we have a book object, it's inheriting from product. We want to check and make sure that a book object is actually being set with fields like name and price, right? That actually come from product. So I've created a test book. It's the same book that I have in the other file. And we're just going to write the test here. So I'm going to start with the test annotation. And I'm going to create a public void method called name field is inherited. And I'll create my little message. You guys know I like to use the message parameter. A new book object is given a name through the product class constructor. So that is a very specific description of what this test is checking for, right? And then I'm just going to do my assertion. I'll just go ahead and do it straight. So assert equals. So we give it the expected value, which is pride and prejudice. And then we go get the actual value, which is test book dot get name, right? We're going to use the getter on the object. And then I can pass in that message as my third parameter. I want to take this time to mention this because I don't know if I can't remember if I mentioned it in my intro to graded assignment 2 specifically. I know I mentioned it last class when I talked about the differences between JUnit 4 and JUnit 5. If you decide to use this message parameter when you're doing your unit tests for graded assignment 2, graded assignment 2 currently, last time I checked, launch code still has it in JUnit 4. So that means that you have to move the message parameter to the front instead of the back. Just keep that in mind. But I've got this one set up for JUnit 5, so that's why I'm putting it last. Okay, let's get back to our regularly scheduled programming. Okay, so we can run this test and see that it does pass, right? We do, in fact, that object it has found that name. It did get set as pride and prejudice, so we're good there. We'll just do one more. Again, public void is always the way you set this up, and I'm going to say price field is inherited. And I'll set a message that essentially is going to say the same thing. A new book object is given a price through the product class constructor. Okay. And then I'll assert equals, and this is, of course, now we're working with doubles. As long as they're the same type, it'll not be a problem. And I'll pass in my message, and we can run this one as well. And it passes, of course, because we already know from testing the code itself that it works. But these are just good examples of very, very basic tests that you can put in place. Like I said, if anyone ever comes along and refactors product in the future and changes the signature, and then maybe the subclasses that are inheriting from it didn't get updated, maybe this isn't getting set properly. And so it's good to have these things in place. Okay, that's all we're going to do with that. Let's talk about diagramming classes. So there's this thing called the Unified Modeling Language. It is mentioned in your book. They also talk about how you can just kind of do this a little bit more informally if you want to. But I'm going to talk for a second about, some of the common actual conventions that are used for this particular way of diagramming. So the idea here is that you plan out a class by giving it a name. you list the fields, and then you designate the methods last. You use the plus sign to indicate something that's public, the minus sign to indicate something that's private. If there's nothing at all, it just means it's package private or default, right? Underline the name if it's meant to be static. Use a colon after the name to indicate the type. And you can see that's been done here for everything. Use italics if something is abstract. And in my, beverage examples, I'm saying basically, I'm never going to create just a beverage. It's going to be abstract. So I've got that in italics. I've got the toString in italics because that's an abstract method that I'm just going to require, soda and juice and everything to have. If you're planning a subclass, you generally don't repeat any fields or methods in the lists here unless you are going to be overriding them. And then in which case you want to make sure to mention them. So that's it. This is pretty much the formula. And there are some tools out there that allow you to, do this really easily. But this particular one is FigJam. That's by Figma. And you also want, aside from just defining a single class and kind of setting all of that up, you also want to set up the relationships. So there's different conventions. This is one of the most common, that you use an arrow to point from the subclass to the base class. And that indicates inheritance. You can use just a regular straight line to indicate like a one-to-one relationship. Like if you had, let's see, I'm trying to think of a good example. If you had one item that only ever had, one other thing associated with it and not multiple things of that same class. And I don't know why I'm blanking. We're going to get into this a whole lot, these relationships. You don't have to worry too much about it now. We're going to get into it when we talk about object relational mapping much later in this unit when we're doing database stuff. So one-to-many is another one, and you use a diamond for that. You'll see this maybe on some of my other examples, but again, don't worry about it till we get to ORM at the end of the unit. But mostly here, what you're seeing is the relationships of inheritance, right? So soda, water, and juice are all pointing at beverage because that's their base class that they inherit from. Diet soda is pointing at soda because that's the class that it inherits from. So it might seem counterintuitive to some of us. When I first looked at this, I was like, wait, shouldn't the arrow be going the other way to show I'm giving you all of these things, you're inheriting them, but it's the opposite. You point to the one it inherits from. Okay, so having that, yeah, I mentioned here about FigJam. That's one of many, many tools out there that you can use. But we can actually get into the bookstore example and talk about this a little bit. Mal, you have a question real quick?
Yeah, I believe you said that methods shouldn't be repeated in the different subclasses. So I'm wondering what you would do in a situation where you have a method that applies to some of the subclasses, but not all of them. So for example, in the beverages, what if you had a method that was like added carbonation and you wanted to apply that to both soda and water, but not juice? And you can't include that in beverage, right? Because beverage is abstract. So, and the subclasses have to inherit all of the abstract methods. So I guess I'm wondering how you would go about doing that.
That would be where you use an interface. And that's what we're going to talk about in the next class.
Okay. All right.
Yep. Because we're gonna do this thing where we have a book and we have a used book. And we want to allow used books to be discountable, to be able to put them on sale, but we don't want to do that with new books. So we're going to apply an interface to used books, so it's not receiving it through inheritance. Yeah, so that's usually how you would handle that. So we'll talk more about it next class. It's a great question. Okay, so the bookstore example, we can kind of see here, I've got this diagram for what we were just doing, right? We have a product class. And, we extend to book and merchandise. Those each are inheriting from that. But we can take it a step further because we have other classes that we would like to, subclasses that we would like to inherit from book, to inherit from merchandise, and, keep carrying down the things that are specific to each of them that they don't have in common. So let's come over here to my actual FigJam. So this is this tool where you can set this thing up and, have all your your different things that you type into your boxes, and have all these arrows that you can adjust. And as you move things around, it moves with it, which is pretty cool. So yeah, it's a handy tool. So you can see I've set this up where I'm representing main, but there's no inheritance relationships there. So I don't have any arrows or anything. But I do have, book is pointing at product, and then I have used book that's pointing at book, because we're going to use this as our base class for used book, so it can inherit everything from book and product. Likewise, over here, we're going to have drinkware and apparel that are both going to inherit from merchandise, which is inheriting from product. So they'll have all the things that are in common there, but they're each going to have some things that are different from one another that need to be established separately. And of course, if you wanted to go crazy with this, you could start adding all kinds of other categories that would inherit from merchandise. We are not going to go crazy because we have a limited amount of time. So let's go get to it. We've got a lot to code here. All right, we're going to start by, let's go over and start with book and used book. I'm going to create a new Java class called used book in the same package here, the books package. And I'm going to extend from book, specifically class 6 book. Okay. And there again, there's that red line reminding me that I'm going to have to define, oh, it says there's no, okay, this is different. Yeah, you might see this too. This actually has nothing to do with the abstract method, the describe method. This has to do with the fact that there's no default constructor available in book. There's a very specific constructor. So it's just warning you, you need to create a specific constructor. You can't just use a default constructor. That's all. Okay. So the fields that we want to have, there's really only one field that we need to have for a used book that's different from a book. And that would be the condition. So I'm just going to make that a string. I'm setting it as final because I don't intend to change it once it's set. And then I can create a constructor here using the generator. And it's going to automatically call super with everything that comes from product and all 3 of these that come from book that are being passed down from grandparent and parent. And then, of course, it's setting condition, which is the one we declared in right here. Yeah. So but we're going to pass all of that in. It's all going to get passed down. And now we have a constructor and it's happy. The only getter that we really need, and again, I can just use the thing here, is for condition. And because it's final, we don't need a setter. We do need to override toString. And what I'd like to do for that is to grab book as a starting point, and we'll just amend it to have the fields that we actually need to have. So in this case, author, genre, and format are already part of super.toString, because this is coming now from book, not from product. So we can just change this to where the only thing left is the condition. I can get rid of these other 2 lines. And we can just change it here with condition. And that's the only line that we're going to tack on. But now we'll have lines from all 3. We'll have the 6 lines from product, the 3 lines that are coming from book, and a new line of our own that's specific to used book. And so again, this is just one pattern that you can use with toString, where you just keep building on it. But for describe, we are actually not going to do that. We're going to write something completely different. And for the sake of time, I'm going to paste it in. But I'll just talk about it for a second. It's gonna, basically, it's the same thing that we did for book. I just added the condition with another pipe right here. But because it's not something where I had kind of inserting it, that's why I'm just defining it all over again, instead of doing what I did here where I'm building on it, because I actually wanted that to kind of be in the middle of that line. Okay, so that's used book. So we could come over to main and test this out. And again, for the sake of time, I'm gonna cut and paste these. Okay, yeah, I have to grab used book. Class 6, there we go. All right, so I have another book. I've got a couple of used books here. I've given them a lot of different values. We've got the Fellowship of the Ring, Fahrenheit 451. We've got A Pocket Full of Rye, which is a Miss Marple mystery from Agatha Christie. So we can print all of these and see, you know, the whole list of all 4 of them. And used book 2. And then we can also do the same thing where we're just going to describe. Let me do this. I'll copy these down. Grab that. Just tack that onto the end. How's that? All right, so let's run this. Okay, so we have all 4 of the books with their 2 strings automatically being called when we go to print the objects. And so we see the same information here, except we also have condition being tacked on to the 2 books that are used books, whereas the original books, of course, don't have that. And then down here, we have our information, and there again, the main difference in the formatting here is that we added that condition into this line at the bottom that has all this information. And it looks like mystery fiction, mystery fiction. I've done something wonky with my, let's see, format, hardcover. That's funny. All right, I'll have to look at that later and figure out what's going on with that. Okay.
Describe function on used books, you put get genre twice.
Yes, so I did. Okay, so if I isn't that funny? Okay, because I would have started with this, which is funny. So the second one should have been format. That's, yeah, thank you. All right, get format. Perfect. Okay, yeah, so now they'll actually have 2 different pieces of information instead of the same. Okay, that's helpful. So that's used book. All we did was add 1 more field. Everything else comes in through inheritance, makes it real easy. And we could just tweak things exactly the way we want them and rely on the inheritance for the rest. Okay, so let's go over to merchandise. Remember that we are passing down a category and a theme. So anything that inherits from merchandise is going to have those 2 now. But we may want additional things for other classes. And we also said that we're not going to define describe here. We're going to continue to make it abstract because this is an abstract class, so that it just gets defined in the other ones. So we'll do that. So we've got drinkware, we've got apparel. We can really choose either one of those to start with. So let's do drinkware. It's a little less complex than apparel. So I'm going to come over here to the merchandise package that I created and say new class and create drinkware, lowercase w. Yes, okay. And I'm going to extend merchandise because I want to inherit not just from product, but also from merchandise. Okay, so the first thing that I want, I need 2 more fields. You know, in my diagram, I said that I wanted to have material and ounces be things that are specific to drinkware. So I can create those private final, string material, and private final double ounces. Yeah, that makes sense. You definitely want a decimal number. And then here, I'll use my handy dandy generator to create the constructor that uses super for everything coming from merchandise, and then assigns values that are passed into material and ounces. I'll do just getters for material and ounces. That's not what I wanted. There we go. Because they're both final. I don't intend to change them after they've been set. And then we'll do our toString. And here again, you know, I really can just borrow from the base class for a second, and then take off the ones that have nothing to do with it. So super.toString in drinkware already contains category and theme because it's getting them from merchandise. So we can just change this to say material, and let's go with volume. And what I'll do here, material and ounces. And then I'm also going to add on another little bit here that just says, you know, in fact, we could just make it OZ period. How's that? And that's all we really need for that. And then for our describe, which we are absolutely required to define here because it's been abstract so far as it's coming through merchandise, we will do something similar to what we did before, but the information's in a completely different order. Because what I've done here is actually say, together with the name that's coming down from product, I also want to just concatenate together the ounces and the material in front of the name. So this is another reason why I don't want to just like tack on to something. I just want to completely redefine it. And then I'll have the description below that. And then I can do the category and the theme and the price, you know, the way I've done it before. But in this case, I wanted ounces of material to actually be part of that first line. So we've done this. We can now go and test this, get a couple of, create a couple of drinkware objects here. I'm going to create a mug and a tumbler. There we go. Okay, so we have an Ahsoka mug. Anybody been watching Ahsoka? It's been amazing. And okay. There we go. All right. I'd make sure it was imported up here. So we got an Ahsoka mug. We've got a Little Mermaid tumbler. Why not? And you notice I've used, you know, with merchandise, we had a couple of new things, right? We had categories and themes. So I've set category mugs, tumblers, theme is Star Wars and Disney. You can imagine that you might have a lot of merchandise that are different types of products and different categories, but have the same theme. And it might be a good way to, you know, track all of your stuff. So that's why I made that part of merchandise so that everything gets a theme, and some items, even if they're different subclasses, might have the same theme. And then we get material and ounces from drinkware specifically, and those are the last two that are tacked on. Okay, so we have those. We can print them like we've been doing. So I'll print mug. I'll print tumbler. I'll come down here and do the same thing. Mug.describe, and then tumbler.describe. Okay, and let's run this. Did I, oh yeah, I pushed it down, didn't mean to. Okay. All right, so now we see that in our product information here for the mug and the tumbler, we, again, we have 6 lines from product, 2 lines from merchandise, and 2 lines from drinkware that have been, you know, continually added to through that 2-string modification. And then down here with the descriptions, we have 15-ounce ceramic Ahsoka mug and 24-ounce, you know, metal, the Little Mermaid tumbler, which really isn't very well phrased, but we're going to go with it because this is a very simple example, relatively speaking. All right, one more, we'll do the apparel. And this one, I'm going to show you some tricks for how to work with array lists and collections a little bit in a way you haven't seen before, so that you might find that interesting. So let's come over to here. Nope, to here. To the, I got to create a new class, and we're going to call it apparel. All right, and it's going to extend merchandise as well. And it's going to have a couple of interesting fields of its own. So we're going to have sizes and colors, but we want to make these array lists. So I'm going to say private final array list and set that to be an array list of strings. And I'll call it sizes and just start with an empty array list. And then I can do the exact same thing for colors. We'll have 2 array lists of strings, 1 for sizes, 1 for colors. Now I can use my generator to do my constructor. You'll notice that it just gives me the super and doesn't give me the other 2, right? So here's what I would like to do. It's inconvenient to pass in an array list, like adding things to it on the fly. It's easier to add things to it after the fact. What I do want to do to be able to actually say, here's the stuff I want to go in that array list up front, is allow for parameters that are actually arrays. So I can say, I'll pass in an array of strings that's the size array, and I'll pass in an array of strings that's the color array. And then there's these cool methods of collections. And we're going to make use of one of them right here. So we'll, use super to pass the values through to the constructors above for all of those. And then here, I'm just going to say, let's go to collections, which is, something that's got a lot of useful methods for use with different types of collections. And we'll say add all. And what I can do here is just say, I want to add every single element that is from size array. I want you to put it in sizes. So you give it the array list and you give it the array. And then we can do the exact same thing for colors and color array. So we can take that information in as an array. And when we actually instantiate objects of these classes, you'll see why this is convenient. So that's an interesting way to be able to just pass that information in and make the constructor go ahead and assign those. But we also could have some getters and setters, and we can have some custom stuff to add or remove things from those lists. So let's do the getters and setters. I'm going to create, okay, hold on. I'm going to create getters using the generator, and I did not mean to put them above my constructor, so let me move those down. Sure, okay. All right, and then I'm going to create some, instead of having regular setters, I'm going to have some add and remove things, and I'm just going to set these like this. But it's just a way to make it easy. Add size, add color, remove color. And then all they do are use the add and remove methods of the array list class to just add and remove things directly. And you can just do it one color at a time, one size at a time. It's a useful thing. But that's kind of a better way to handle something with array lists than to have like a traditional setter, because we've made our array list actually final because we don't want the entire list to just be overwritten. We only want to be able to add or remove things from it. So that is something to keep in mind. All right, so the last part here, we've got our methods, our toString, and so I'm gonna go back here to merchandise again. And where's my apparel? Everything's out of order. Okay, there we go. And I'm just gonna say that I want sizes and colors. And you're thinking, but Carrie, those are array lists, those aren't strings. It's not a problem, guys, because we have something that's gonna help us. You can use the string class to call join. And you can say, here's the delimiter. I want you to join it with a comma and a space. And here's the thing that I want you to join, and give it the array list. So just like that, I've joined together everything from sizes, and now I can do the same thing with colors. And it makes it into a string right there for me in the middle of my, concatenation. It's very handy. So there again, just wanted to show you guys something else cool you can do that's handy. Okay. And then for describing, I'm going to do something kind of similar. I'm going to go ahead and just paste it in because we're starting to get close to time. Okay, so this time I'm still using the new line, the pipe. I'm putting the name on one line, the description another line. I'm essentially doing the same thing I do in the toString, but I just said available sizes, available colors, and then the rest of it. So I kind of inserted that stuff in the middle. So there again, I'm writing a brand new definition, but it is in keeping with, the style of the way I'm doing everything else. Okay, so we have an apparel class that inherits from product and from merchandise. So let's come over here and get our last couple of objects set. Sorry, give me a second. My other window over here got a little funny. Okay, so I've got a hat and a t-shirt I would like to add to my shop. And so we've got a Captain America hat. that has one size as the size and navy and gray as the colors. Now, you remember I said that we were going to make it easy on ourselves and pass in arrays. So I just said new string array, and then I put the value between the curly braces, and then new string array, and then put both of those values together between the curly braces. And right there, I created a Java array, which then using that collections add all can be, dumped over into our array lists. So it's a very quick, short way to be able to handle that. And then I did the same thing for t-shirts, right? So I've got 5 different sizes that I just quickly put into a new array here and fed that in, and then our class takes care of assigning it to the array list. And then here, just one color for the shirt. So this is a Batman shirt. I show lots of love to Marvel. I don't often show love to DC. I figured it was high time I did that. Okay, so let's print our hat and our shirt. And let's come down here and describe them as well. Okay. And t-shirt, there we go. All right, and I also had here where we're going to test out those things that we did in merchandise where we said increase the quantity or decrease the quantity. So I wanted to test that out here. So we can just say hat dot increase quantity and give it 5. And then I'm going to print hat dot get quantity to just use the getter for that one field so we can just see that value. And I forgot to call it. So let me do that. There we go. And I'll do the same thing here with a drinkware object. Let's just use the mug. We'll say mug dot decrease quantity. And I'll say decrease it by 1. And then I can print mug dot get quantity. And that quantity, of course, is coming all the way from product. That was something that we established way at the top in our very first abstract class as a way to affect quantity differently than just setting a flat value and overriding it. Okay, so let's test all of this out. Let's give this a run. All right, so we have all 8 of our objects are described here. You can see how the product information for the drinkware has everything from merchandise and product plus material and volume, whereas the apparel has everything from product and merchandise, but it also has sizes and colors. And you can see everything is nicely just listed out because we used that string dot to join there. And then down here, oh, and then right here where we changed the values, we printed that the new quantity of the hat was 10, the new quantity of the mug was 2. And then, of course, here's all of our describes, and we can see how they all are, similarly styled, but they're unique to display the information that's unique to those classes a little bit differently than the others. Okay, so who has questions? Because this was a lot, I know, and this is actually scaled down from the last time I taught this, if you can believe it. But I wanted to give you lots of examples of how this works because it's going to be useful for when you go to do the last part of your graded assignment too. Oh yeah, got the link to the Fig Jam on here for you guys in the slides. No questions at all? Any? Okay. Well, as always, I have, hidden slides in here that have links to my code and things like that. So you guys can feel free to come in here and take a look at all of this. You just have to switch over to the solution branch to see it. I mean, you can see it even just in, you can just go to it and see it, like this, by just switching to the solution branch here on my GitHub. But you can also clone it down and play with it if you haven't already cloned this repo. It's got a lot of stuff in it. Okay, well, we actually did great on time then, if there's no questions. So coming down the pike, we've got interfaces and polymorphism on Monday. That's chapter 8. And then we are going to start getting into using Spring Boot. So we're going to talk about Spring controllers and routing for, using HTTP methods to display and receive information from pages. Then we're going to kind of jump away from that for just a second to talk about exceptions and IntelliJ tools in class 9. And then when we come back to class 10, we'll be coming back to Spring and just going gangbusters to the end of the unit. They're doing a Spring Boot project with Java, and we're going to get into SQL databases and stuff. It's going to be cool. Don't forget you have a catch-up class on the 28th, and then graded assignment 2 will be due the Monday after that. All right, so tonight's studio. The chapter 7 studio is a quiz that you are going to design and code. I highly recommend that you do this in pair programming. It's going to be a little overwhelming if you do it individually. You really want to bounce your ideas off of each other and come up with something that will make sense, because you really do need to design it first. It could be a piece of paper. It can be a Google Doc. You could use FigJam or another tool like that if you want to. But honestly, don't spend too much time on this part, because just make that part quick and dirty, because you really want to get to the heart of it. What data do you need in which class? What kind of hierarchy and structure do you want to have? Do you want to have an abstract class that just passes things down to subclasses? How is all of that going to work? Just going to figure out what fields and methods are needed, that sort of thing. They tell you to create at least 3 classes. Question, and well, actually you'll be creating, at least 3. You'll be creating way more than 3. Question, and then there's going to be different question types. So that's what I mean by that. And then quiz that will actually, let you put together a list of questions. And then a quiz runner with a main method that actually runs the program, takes user input so that they can answer the questions and you can grade them. But you're going to create a new Java project for this. It's going to be separate from that repo you've been using for most of your other studios. So the instructions are in the book, and I will leave you guys to it. Let you guys go off and get started. This one can take a while. There's bonus missions too, guys, but honestly, you're going to spend the whole time just getting this part worked out. So, however, I am taking the time this time to put the bonus missions, most of them, in my video. So I don't know if I'm going to have that done by the end of class tonight, but it will be up tonight, even if it's much later. It's got to be longer, because I'm going to do all of this, plus I'm going to do the bonus missions, most of them. And then you guys will have all of that to refer to, and hopefully it'll be useful. It's probably going to be completely different than what some of you come up with. Everyone's going to have completely different solutions, and that's what's really cool about this kind of project. But it also can feel a little bit overwhelming, and that's why I say work in pairs or groups, 2, 3, 4 people. Put your heads together. You'll get a lot farther, a lot faster on this type of project. Okay, so you guys head off and have a good night, and I will see you on Monday.